Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 20th, 2025, just yesterday. The main punchline is a zero or few shot 3D editing system that produces multi-view consistent edits from only one or two images with no per-scene fine-tuning. The paper is titled, Tinker, Diffusion's Gift to 3D Multi-View Consistent Editing from Sparse Inputs Without Per-Scene Optimization. And as we will see later, the results are really impressive. Beyond editing, the framework handles novel view synthesis and rendering enhancement efficiently by repurposing pre-trained diffusion models and a curated multi-view editing dataset. Also, the author shared a GitHub repo. You will find the README outlining Tinker's goal of one-shot and few-shot 3D editing without per-scene optimization, an assets folder, and notes on the planned data pipeline, scene completion model, and 3DGS editing with Nerf Studio. It includes licensing and citation details. Alright, this figure shows the overall promise. You start with sparse original views on the left, pass them through the Tinker pipeline in the middle, and then see multi-view consistent edited renderings on the right. The left block emphasizes that inputs can be just one or two images. The center panel highlights no per-scene fine-tuning, which is key because it keeps editing fast and scalable. The right panels illustrate both object-level and scene-level edits that remain consistent across viewpoints. Building on that overview, this figure contrasts pairwise editing with truly global consistency. The left column shows that concatenating two views yields consistent edits within each pair, yet the two pairs disagree, so cross-pair consistency breaks. The right column then tests referring editing, where an edited half should guide the unedited half, but the model either fails to change it or produces mismatched styles. The takeaway is clear: pairwise tricks are not enough, which motivates a dedicated cross-view editor. Next, this figure walks through the full editing pipeline end-to-end. We start from the original 3DGS, render short videos, then pick a few sparse views that feed the multi-view consistent editor to create reference edits. In parallel, Video Depth Anything estimates depth for the rendered frames, which anchors geometry and camera pose. The scene completion model then uses those edited references, plus depth, to synthesize dense, consistent frames, and those frames optimize the 3DGS into the edited result. Moving to the results, this table compares quality and cost across recent methods. You can see higher is better for CLIP directional similarity, DINO similarity, and the aesthetic score, while lower is better for average editing time. The few-shot variant leads on all three quality metrics, and it stays practical because it runs on a single 24GB GPU with about 15 minutes per edit. The one-shot setting is close behind, still faster than most baselines. Building on those results, two takeaways stand out. First, multi-view consistency from just one or two images is now practical because the referring editor and depth-guided scene completion unlock latent 3D awareness in diffusion models. Second, no per-scene fine-tuning keeps edits fast and scalable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.